So we had the assignment to trace this code and explain what exactly is going on. Whoops, that's the wrong one. There we go. It's doing a division, integer division, doing a printout. The question is, after you trace it, to write in a couple sentences, what exactly is this doing? So let's end up talking about that. So if you're going to give a straightforward explanation for this in terms of layman's terms, in other words, somebody who doesn't understand anything about code, like your mom or like your dad, the solution would be it strips off the last number of the value each time. So first it cuts off the 5, then it cuts off the 7, then it cuts off the 4, then it cuts off the 3, then it cuts off the 1, and then finally it throws out a 0. So that one you'd have to explain a little bit. It throws out a 0 at the end. It does print the 0. Because this says while num is not equal to 0, divide it by 10. So the result, the printed out result, will include the 0 because it takes the value and divides it by 10 first. If you kind of reverse that and put the num by 10 after the print, then it would not print out the 0. The order of this does matter. So when you do your tracing, your table should have looked something like this. Hopefully this works. Hang on. That's interesting. Okay. I guess I'm going to type it. Give me a second. That's weird. Okay. So we're going to type this. We should have a spot for num. We should have a spot for the screen. And that's it. That's the only thing that's changing. So when this first starts, num is 1, 3, 4, 7, 5. It doesn't equal 0, and the screen's is blank. So you should have had that in there, that the screen is blank. Some of you did not, but you should have that in there. Then the next line says num is equal to num percent 10. So what's happening here, it's doing integer division. That's why it's fine to put it inside of an int. It's doing integer division. That's why it's okay to put it inside of an int. So when you do integer division with this by 10, it's 1, 3, 4, 7. Right? So we're going to divide that by 10, and we get 1, 3, 4, 7. And then it's going to print out num, which is going to be 1, 3, 4, 7. Notice it does not print out the original value. The first time through cuts off the 5, and it doesn't print out the original value. So, actually I should do this first, blank, and then 1, 3, 4, 7, and then the screen would be 1, 3, 4, 7. So this is a full run for the first iteration. We should probably put that in here. Iteration 1. Space this out a little bit. So this is all the first iteration. Or actually, I should say 0 iteration. And you might need to do one more to figure out the pattern, but I think this is a pretty straightforward pattern to figure out what's going on. The only question would be what happens at the very end, and at the very end, it does take and divide the 1 by 10, which ends up giving you a value of 0. So it will print out the 0. So it does the calculation before it does the test. Calculation, print out 0, then come back up and do the test again. If we change the order of these two statements, swap the num divided by 10 with the printout, that would make a big difference. It would not print out the 0, and in addition, it would have printed out the first value. It would have printed out the 13475 the first time. So that's the code explanation of what this does, but the mom explanation is it cuts off the decimal, it cuts off a value each time by the lowest value and goes from there. So here's another short little one. What I'd like you to do is take a look at this one, and I don't want you to go through a full trace. You can if you need to, but I want the mom explanation. What's the mom explanation for what this code is doing? Pause the video and then give it a try, and then we'll talk about the answer. So the mom explanation for this, you want to keep it as simple as possible. Say what it does. The print statement's outside the loop, so the mom explanation would be, this sums all of the numbers from 2 to 19 and prints it. It adds up all the digits from 2 to 19. That's something mom can understand. Mom's not going to understand if you say, well, it starts counting at 2 and then keeps counting and adding it to itself. That's not what it does. As far as mom's concerned, the only thing mom sees is the screen. Mom doesn't see this. Mom only sees a screen. What's the real final result is what you're looking for, not the code explanation. That's where we need to get to be able to separate tracing from explaining. So let's try another one. Maybe. Take a look at this one. Tell me what it does. This time I made sure I declared double, so it's safe. If you start to look at the trace, right, it starts with a 1, and that becomes sum. And I'm going to kind of write this out this way. This is sum. Here's x. X is 1. So they both start at 1. Then we do sum times x, which is 1. Excuse me, I missed a 1. So sum times x is 1, then x becomes 2. I know I'm kind of shortening my trace a little bit. And then this becomes 2, and this becomes 3, and this becomes 4, and this becomes 1 times 2 times 3. So our final value, when we go through this, this will be 19. X gets to 19. So it's 1 times all the digits all the way up to 19. 1 times 2 times 3 times 4 times 5, which in essence is 19 factorial with 1 glitch. And it's technically not that big of a glitch. You could very easily explain this is 19 factorial. The only glitch is 1 times 1. Right? Because technically that's not part of a factorial. But it doesn't really change the answer. It's mathematically equivalent to a factorial. That's what this is doing. Calculates the factorial for 19. Right? You could also talk about this as some type of geometric sequence, but it's not multiplying by the same number every time. So you can't really say it's a geometric sequence, but you could say it's a sequence. You could come up with some type of sequence formula for this in order to get the final answer. It would not be easy because you couldn't, it's not geometric and it's not arithmetic, but you could say it's a sequence at that point. So hopefully you understand what I mean now by saying there's a difference between tracing the program and saying what it does. The saying what it does part is probably the hard part. Really saying it in flat-out layman's terms, explaining what this does. We're going to talk later about something called an algorithm. And an algorithm is some type of looping iterative process that does something. The purpose is to accomplish some type of goal. We're going to take some time and look at those and try to understand what the algorithm is meant to accomplish. In other words, what's the mom explanation for the algorithm? Not just the trace. Because sometimes it's really difficult to identify. And in fact, sometimes you can get paid a lot of money if you can identify what an algorithm does. Currently in the financial markets, there are algorithms that are floating around that are meant to track stocks so that way they can make instantaneous buys and sells. And they're just out there for people to see. But the algorithms are very complex. And unless you can really pull apart that algorithm and understand it, you're not going to be able to figure out what it's actually meant to do. So they actually pay people. One financial company will pay a person to come in and look at another financial company's algorithms to try to figure out what they're really trying to do. What's the mom explanation? You can get paid a lot of money if you can do that. That's a really important job. So if you're interested in these types of algorithms things, kind of start, and maybe even financial markets, start thinking about there's a direction you can go with that. Okay. So we have inside of the blackboard, you already did the U-try, but we have a tracing code exercises for you to submit. It's a PDF, so you can't really write on this, but if you want, you could just submit your entries. Just do this. Here to just go through and trace what each of these are. What I really want out of these is answering the question, but also I want you to be thinking about what's the mom explanation for each of these. You know, how would you describe to what is actually happening in each of these pieces of code? Okay? And then there is a challenge trace. This is kind of tricky. And I really want the mom explanation for this. Not just the answer to the question, what is the first and last output number of the following code? I also want you to tell me, if you can, what is it really doing? You may not be able to. This is actually kind of tough. Go through and tell me what you think this is actually doing. So you have those two assignments to work on before we do the next lesson. Okay?